Alright, today we're looking at forces and structures. Okay, so you can see here I've got 5 questions, and we'll start with the first one. What is a force? Okay, so this is like science, so maybe you've done already, I don't know. What is a force? A force is anything that can cause a push or a pull on an object. Okay, it is measured in newtons. What is a structure? A structure is any object that is either man-made or natural, and it can be made up of many parts, like a building or a crane or something like that, or it could be of one part, like a lunchbox. Where do forces that act on structures come from? Right, so where do these forces come from? Some of them can come from, gravity. It could come from the structure itself, the weight of the structure itself. It could come from the environment. It could be wind, it could be waves, rain, earthquakes, that kind of stuff. Or it could be moving parts that are on top of the structure or inside in the structure. Right, that can cause a force to act on the structure. Why is it important to understand how forces impact structures? Okay, it's important to know how they impact on structures, because if we're designing something in the future, if the structure is not designed to withstand those forces that are going to be acting on it, the structure can fall and break. So an example of this would be if you're building a bridge and you don't make it strong enough, then it can fall apart and break, and that could be catastrophic, obviously, because people could be driving over that bridge. And the last part there, what determines how strong a structure is? There's a couple of things that will determine how strong the structure is. The first thing is the material that it's made from. Okay, so do you use good quality and strong materials? We studied those there in the last chapter. What is the shape of the structure itself? Okay, so that will have a big bearing on how strong it can be. And the type of force that is acting on the structure. So, you could use very, very weak materials and there might be very little forces acting on the structure. And that's okay, because it doesn't need to be resistant to many forces, okay? So those are 5 questions. At the end of this, you should be able to answer all of those. And I want you to do that. I want you to answer all those 5 questions, okay? So moving on to our first force. So my first force here is compression, right? We can see I've drawn an object here. It's not an object in particular. It's just a block. Take maybe a block of timber or something like that. The object is being squashed together from both sides, okay? 2 opposing forces are pushing against it. So look at those arrows there. There's one force pushing down from the top, one from the bottom. And you can see that the middle of the object is bulging out. A material that can withstand this type of force has a high compressive strength. Okay? So, what I want you to think of is, can you think of a material that is high compressive strength? Something that is good in compression, that won't fail, it won't break. Okay? And I want you to write it out and put it in there. Secondly, I want you to think of a real life example. Where in the world have you seen a material or an object or something like that that has high compressive strength, or where compression is found? Okay? So I want you to write that in there. Now you can use Google or whatever, you can ask your parents or ask someone else. Where in the world could you see compression? Okay? That's compression. Tension is the next one. What we can see here is a similar object to the first one, except instead of pushing down on the object, it's being pulled. Okay? The object is being stretched in 2 different directions. An object that can withstand this force is said to have high tensile strength. Okay, so I have a few ideas in my head of a material, and I'm sure you have probably the same ideas too. So the material is here, and again a real life example of a material that can withstand that force. Okay, something that won't snap or break when a tension force is being put on it. Okay, moving down here to torsion. Just move my camera. This object here is clearly being twisted around. Okay, so it was originally a square object, and someone grabbed it at the top, grabbed it at the bottom, and twisted it in two different directions. So the explanation is right here. The object is being subjected to a twisting force. That is torsion. Some of us might have heard of the word torque before. Okay, torque is a twisting force. A real life example. Okay, so I'm not looking for the material here now. I'm looking for somewhere a twisting force is used. Next one is shear force. Now I'm not talking about shear as in like raw strength. I'm talking about two forces pushing on the object from opposite sides. Okay, so we can see my arrows here. They are not directly one over the other. One of them is over here on the left hand side of the object, one of them is over here on the right hand side of the object. One is pushing up from underneath and the other one is pushing down, and this caused it to break in the middle. So it broke in the middle here. This causes a sliding or shearing force which can break or tear the material. Again, I have a couple of ideas in my head of real life examples. You might be able to come up with one as well. So a real life example there, take that down. Last one is a bending force. Okay, so in the diagram I've shown here, I have two supports, one on the left, one on the right, and I have a beam going across, bridging the gap between the two of them. Okay, so the supports aren't really anything to do with it, but the beam is what we're looking at here. So when we put a force in the middle of that beam, the top of it is said to be in compression, and the bottom surface of that beam is said to be in tension. So all the little fibers at the bottom surface of that are being stretched to the left and to the right. Okay, so a bending force is a combination, or can be a combination, of compression and tension. In the picture above, the bottom of the beam is said to be in tension. As I said, the fibers are being pulled to the left and the right, they're being ripped and torn, and maybe you could see, like you've seen that on a hurley, if you bend it before you do a sideline cut, so if you bend too far, it rips apart on the far side and breaks the hurley. Whereas the side you were pushing on, the side that the compression was on, that doesn't break, that side. Okay? The top of the beam is in compression. So again, looking down at the top, there's a force acting downwards on that. It is in compression. The dotted line in the middle, however, is neither in tension or compression. That dotted line is a neutral line. It is neither in tension or compression. So what I want for your material example here is, I want an example of a material that is able to withstand bending, something that does not bend easily. Okay, and then where in real life might you use that? Where in real life might you see this setup where you don't want this to bend? Okay, that's our 5 forces. I'm going to flip the page over, and here's a little question. Okay, so what I've drawn here now is 3 metal bars. Right, these 3 metal bars are kept together in the corners by nuts and bolts. Okay, a force is applied to the structure, pressing down on top of the top, where of the triangle, we'd say. So what I want you to do is take a stab at what forces are acting on this structure. Now I'll give you a hint. There's 2 of them. There's a force going in this direction, and obviously in this direction as well. And then since there's a force on this one, and these are tied together, then this has to be a force as well. So I want you to tell me, what are the forces that are applied to structure. Okay?